Hi again, Jan Sverre here with my CX-16 saddle. Carrying on from last video where I measured and scraped the bottom and top surfaces of the saddle. These were really the easiest part and the one which I could do with at least what I think is a high degree of certainty that I had minimal wear, maybe not wear at all, just bad machining or spring in the casting, at least touching here on the outer corners, meaning here from the underside, the bottom view here, on all four corners, and then just taking it straight down, meaning that scraping straight up here. Of course, having this inverted onto the granite, and then scraping the top surfaces after measuring along here, that I had it even with the plate on the underside. So that was the easy part. And now the more trickier part, where I at least think I really needed good references, namely the dovetails. And this is a rather strange design where you have a long surface here, but it's only bearing on this down to here, I mean halfway. But anyway, on the side here, going to the base, and the top side here, of course, to the table. So the table will ride here. And it's of course absolutely critical that it is 90 degrees here, so that the table will travel exactly perpendicular to the saddle, and that the saddle also travels directly into the line with the head of the milling machine. And of course, it's also important that in addition to being exactly 90 degrees, that it's also traveling in the same planes, so that when you travel the table from one side to the other, like so, and the saddle in and out, that they are moving in the same plane, or at least co-planar, not the same plane, but two planes exactly matching. So to accomplish scraping and matching the dovetails the way I want, I need good references. And references needs to be to the way system, the same, let's say, along the length of the way system. In this case, along the length here and here. I mean, here and so. And since the sides here were all painted, I couldn't use the sides to, like I've depicted here, to place the casting directly onto the plate, so I had to remove the paint first. I removed the paint here from the side to go down to bare surface here on the side, one side, and to the end here, to see if I could use these as references. And the problem with such a machine is that I mean, not a high-end like or a Bridgeport or whatever kind of industrial machine where all this is good and can be trusted. On such a Chinese mill drill copy of a Goldmatic, it's not precise enough, or at least it turned out to be so, to be used directly as reference. This just the way it is. It's a budget machine, and I found that the side here was the best of the references. The end, bottom end here, was not really useful as reference. On the end here, I had this end was a little bit bowed, with touching on the ends, but from the side here was also not exactly 90 degrees, as I found out. So all in all, when you buck up a square, for instance, having the saddles, this is the same saddle, but just depicted on the side and on the end. When you buck up a square to this now, here, and measure that way, and here that way, and also on the side here and here. You shall have, of course, ideally everything to match up so that everything is exactly perpendicular to the table. That was not so. The best surface I could find was this long surface here. And I wasn't too concerned about this being exactly true. So when you measure this way with the square like so, that it was sitting exactly perpendicular, but more so that this long axis here was measuring okay. And the way that I measured that was from that reference to the dovetail, to see, of course, then not knowing that it could be where on the dovetail that I would be measuring correctly, but at least to find out which was the best. And I found that this, for instance, and this surface was way off. That corresponded to the measurements I'd done on the sides. And that I found out by setting, of course, first I blew it up and saw that this was only touching at the corners here, and that this was touching moreover at least along the length. So I put the casting onto the granite here, and then I measured the dovetail, and that was consistent, apart from a small deviation at the end there, was consistent with that reference, or to be tested as reference. Okay, I did the same here and found it wasn't. And I also boxed up a square to the side, like so, and so, and also like so, and so, and from the rear here, I mean like so. So I could see if these were 90 degrees, like so, every way, and I found that it was consistent, so that I knew that this was the best reference I had. So I made a decision to trust this, and then saw that I had minimal scraping to do on that side to get it in alignment. And on this corresponded, the error I measured, to the fact, if I bucked up a square, so the error there, so if I corrected for that error, this way also came in. Okay, then I knew. I also made the measurement using the milling machine as a CMM, so I put the casting onto the milling machine, square it up like using the reference on the side, and just clocked it in so this was straight, and then I measured along here, the rear, and also here to see, and then I saw that this was the same error. This is not 90 degrees. So then of course I could have adjusted that on the rear here, and that I probably would serve me better, instead of having to measure it in an awkward way each time in between scraping sessions. I could do this as a reference then, I mean correct it, so, and then it's much easier just to put it on the plate than to use and clock it in the milling machine in between each scraping cycle. So that would probably serve me better, but anyway. So having used the square to test all surfaces, found that at least this was the best, scraped this too much, and then I have then, as I said, established where this was wrong, and then I can scrape this, so I know that now when I use the straight edge, what to expect really, and then just make this surface even with the correct alignment, and sort of prepare it for spotting. The final spotting will be done anyway when I match and mate everything together. But the critical point here is the references, and to get that right, remove the paint, see what is going on, measure to find out, and then after that start scraping. I mean, the most valuable lesson, as I said before, be a detective. Find out. That's on top of the basics of scraping, of course. So it presented a problem really, and the whole problem is just because it's not machined as accurate as you have on an industrial mill, because this is not an industrial mill. This is a copy of a high-end machine, but still just a budget machine. So you can't expect everything to be to have let's say be as accurate, because it's not costing that much money really, and can't spend that much time on everything. I'm not really certain if the casting are probably a little bit bad, so the 100th of mil deviation I got from true was probably more like just spring in the casting than wear or bad machining. The same probably here on this, but could also be a little bit bad machining. Here we had the ground surface on the inside dovetail. Here, the same here, really. And then after scraping, of course, that improves a lot. So it's been a fun project so far. So let's dive into the, well, not just on a drawing here.